I'm Roberto Baldwin, and this is Tomorrow Today's Sustainable Mobility Brief. The transportation world is evolving at a rate not seen in decades. The transition from fossil fuels to sustainable energy has brought with it some truly exciting opportunities, but also some confusion. I'll sift through the noise and share quick updates on the latest news, trends, and advancements that will impact our world for years to come. This week on the Tomorrow Today Briefs podcast, we have J3277 sponsor Hemi Sagi. Hemi, thank you so much for joining me today. Let's talk about something that I don't think a lot of people they're concerned about it, but in a very weird way, and that is water. Water and EVs. Now, I've had people ask me, can they charge their EV in the rain? Which, yes, you can charge your EV in your rain. But what's your reaction when people ask you about EVs and water? Like, what is your biggest concern?
So, Roberto, thank you. First, thank you for having me here. So we need to realize that vehicles in general are not designed to drive in a lot of water. They can be exposed to water for a short period of time, but they are not designed to stay in water for a long period of time. And when it's coming to water and a battery pack or electrical vehicle, the battery pack in most vehicle is mounted, in most EV is mounted on the floor, basically. It's the floor of the vehicle. So obviously when you go through a puddle of water, it will be exposed to water. Of course, when you drive in rain, it can see some water. So that should not be an issue as long as two parameters typically fulfilled. One is what's the depth of the water, and second, how long are you in the water? Okay. So first, the Chinese regulators mandated in 2020 that the battery packs, or the technical term for them is rechargeable energy storage system, or RESS, should be able to withstand 1 meter of water for 30 minutes with no damage, no safety issues, and so on. So this is a mandatory requirement that today most EV manufacturers comply to that, try to comply to that. What do we need to protect inside the EV battery pack from water? So the most sensitive item inside the battery pack is the lithium-ion cells. When they make the lithium, and there's few hundred lithium-ion cells inside a single battery pack. And when they make these lithium-ion cells, they make them in a special dry room. Lithium-ion, when it sees even moisture in the air, goes through exothermic process. It's getting hot and getting on fire very quickly. So that's why when they make that, when they manufacture those lithium-ion cells, they manufacture them in special dry rooms, and then they leak test them to be very, very tight leak specs so moisture cannot go in. Okay? So that's the first level that is protected today. Then the second topics we need to protect the battery is when they assemble the battery pack and close it up, it should not be able to let water penetrate it above minimum allowed, and it should not also have coolant, because the battery has a coolant liquid circulate there to cool it off. It should not have coolant leakage into the battery pack at no time. If you have too much water, and it depends where the water is, but it could cause a short in the control circuit board that they have inside the battery pack, and that can lead to a thermal rundown, heating up the battery pack, which results in, of course, damaging those lithium-ion cells that I manage, and then this all go to a what we call thermal rundown or fire that is very different to extinguish, very difficult to extinguish. In the last 10, 12 years that I've seen battery pack leak tested, it starts from pretty open spec. Manufacturer did not realize how the sensitivity, but in the recent years, the newer EVs are tested to a tighter spec. So if you have a situation like in Hurricane Ian, that the battery pack sitting in water, deep water, for 8 hours or so, it is not designed to withstand that. Whether it will generate fires or not, it depends on the OEM or the manufacturer of the vehicle and what are his requirements. And then we can talk about it. So the functional requirement that is most popular now are the Chinese functional requirement called IPX7. Battery pack should be able to withstand 1 meter of water for 30 minutes or 2 hours of salt water with no pressure on it. Just be covered. The amount of water that penetrates into the battery pack when you have a leakage is, of course, is dependent on the defect size of the leak path diameter and length, and the pressure to drive the water in. So if you don't have any pressure, very little water will go in. If you have 1 meter of pressure, which is about 9.8 kPa, a kilopascal, then you'll get more water. So from us in the leak testing business, the requirement of IPX7 is a tougher requirement. So that's what we call a functional requirement.
And, with changing weather patterns and, rising seas and, we're seeing these hurricanes are a bit more powerful than they were before. And of course, there are more EVs on the road where an EV is partially submerged. So how does, the standard J3277, what does it do to help alleviate this issue? Or at least, for some people, hopefully for most people.
So there's 2 steps to that process. Step 1 is what is the functional requirement? Functional requirement is what is the battery pack to be able to withstand. If it be able to withstand what the Chinese call 1 meter underwater for 30 minutes, then what it is, that's what it should be designed and withstand that. NHTSA, based on EON data that they received in the past few months, is reanalyzing and redefining their requirement for the U.S. vehicles. But right now, the most popular requirement is this functional requirement of 1 meter for 30 minutes. This is a functional requirement. Now, when we make millions of battery packs, okay, and we cannot take each one of them and dunk it in water for 30 minutes to see if it's leaking. It's not practical because it's totally sealed. So to see if water get in, you have to open it up again. So this is not practical for production quality control and quality assurance. So the purpose of SAE 3277, take this functional requirement, whatever it is, 1 meter of water for 30 minutes or 1 meter of water for 8 hours, and to convert it into a production type of leak testing requirement that manufacturer can use when they make this battery pack. And that typical requirement, that typical challenge exists in the auto industry for years, how to convert functional requirement. For example, in the early 2000s, it was no methane or carbohydrate emission to the world. So OEMs wanted to make sure that there's no hydrocarbon emission due to leakage. So how we convert that requirement to production leak testing. So in early 2000, I worked with Ford and the U.S. car industry, and we came up with this concept rather than asking, and then how you convert that requirement to production leak tightness, that you get an instrument and set it up and run, hundreds of thousands of parts through that. The concept that we came in early 2000 for the fuel automotive industry, asking the question, what is the maximum allowed pinhole that we can have that will not let gasoline leak out at that time? So we applied the same, this pinhole, certified pinhole, we define it as, we call it equivalent channel, which is basically a micro channel that have X micrometer diameter and Y millimeter length. And so SAE 3277 took the same similar concept and say, okay, we know that we can have either a very small amount of water leaking into the battery pack within 30 minutes or 8 hours, whatever the functional requirement is, and then how we convert it to a production leak tightness, and what is the maximum allowed pinhole or leak path that we can allow. So the SAE J3277 is information report that its function is only to convert this functional requirement into a production leak testing requirement. And so, but if you know that, for example, you allow the maximum allowed to meet the Chinese requirement, you can have a microchannel of 20 micron on 3 millimeter long, for just an example. Once you know that, you can attach similar device. You can make similar device and connect it. We call it calibrated leak, and connect it to your leak test instrument and make sure you detect it. Most leak test instruments today using some sort of gas flow measurement. So if you know the pinhole size or the equivalent channel size, you can define the flow limits and set up the instrument accordingly, or at least make sure that when you take a battery pack that is 100% inspected, there's no leakage there, you attach this to it in one way or another, and you make sure that you reject that battery pack. So that the purpose of the SAJ 3277 is to take a functional requirement. In that standard, we use IPX7 because since 2020, this is the most popular standard. But if somebody come with a different standard for water ingress, we can convert it to a leak tightness requirement. SAJ 3277-1, which is come in next couple to 3 months, is already tell you how to use common leak testing technologies to test it in the production line. And the whole purpose of that is to make sure that once the battery pack is tested, it's a non-destructive test, it should be able to maintain the functional requirement that was defined to it. So if the functional requirement is IPX7, 1 meter for 30 minutes, that's what it should meet. If the vehicle is in the water for more than 30 minutes, for a few hours, that's a different story. Then you may have a problem.
How is this implemented? Is it implemented? Do you foresee this implemented at the battery pack manufacturing facility or on the automotive line? Is it going to happen right before they stick it in the vehicle, or before it leaves the facility to go to the factory for the cars?
The battery pack leak tested in multiple steps during its assembly. Of course, as I mentioned before, the first thing it's done is when the manufacturer, the lithium-ion cell, they got to be very carefully tested to very tight spec. We don't have now, just to give you an idea, we cannot have a pinhole of 1 micrometer, okay, inside the battery pack. And in a regular microscope, you cannot detect 5 micron. You can detect probably 10 micron. So 1 micron is too much already, defect size. So that's just to give you an idea of a pinhole. A wavelength of light is 0.5 micron. So it's very, very small. So that first level have to be tested and assured before even it get to the battery pack assembly line. In the battery pack assembly line, they test, before they close the battery pack, they test the cooling system. And the cooling system goes to a spec that we do not allow any sustainable leak for coolant. None, not even a drop in an hour. So that the equivalent channel, the SAJ 3277, gives you an example how to test for that. And we actually ran some tests and give you some initial data. If you have different liquids, that what we, common liquid coolant today is G48. If you're using a different liquid or different chemistry of liquid, of course you have to test it for that liquid. It's dependent on the liquid side. So that's the second test that is done. Once the battery pack is fully assembled and sealed off and charged, it go to its final leak testing process and for water ingress protection. And they're done in the manufacturing side. When it comes to the assembly line, they don't have the time to do that, nor the means to do that. So it's assumed that it comes like any other automotive component, tested before it gets to the final assembly line.
Cool. Well, thank you so much for explaining that to us, Hemi. I really appreciate it, because I don't really think about the idea of water. You're like, okay, water and electricity, they're bad. They don't go together very well. And you do think, you're like, okay, well, some EVs, like large SUVs or outdoorsy vehicles, like they have, they're like, yeah, you can drive through 30 inches of water, but it's not for, first of all, it's not a meter, and it's not for 30 minutes. You're usually just kind of splashing through it. So thinking about the ability to keep that water out of the battery pack, like it's just one of those things. I think a lot of people are like, oh yeah, it probably just does that. But the testing for it, like how you would test for it, like you said, it doesn't make sense to like grab a battery pack and then just shove it underwater for 30 minutes and hope for the best.
But yeah, well, it's even not very, very smart, not very safe. But so if you drive through a paddle and it takes you a couple minutes to cross it, you should be fine. There should not be any issue if you meet the Chinese regulation or any others. I just want to let you know that the battery pack has a safety aspect for water. They can go to a thermal rundown that is very, that once it gets into fire, there's toxic flammable gases that form that is very difficult to extinguish those. But if you look on your LED lights, they also need to be water protected. They cannot take water. So this is not the only electrical component in a vehicle that need to be protected from water ingress. So even in today's vehicle, engine component, the ECM, engine control module, transmission control module, all are tested to be leak tight, just so they won't get damaged. So similar requirement. Yeah, and it's not, our common vehicle are not designed to be amphibic vehicles. So they're not designed to drive in water.
Well, it turns out, don't drive your car is not a boat. Regardless of whether or not it's an EV or an internal combustion engine vehicle.
When you put the boat in the water, make sure that the car is not go follow the boat.
Yeah. Well, thank you so much, Hemi. I really appreciate it. Yeah, there is I'll put this in the show notes, but there is Hemi wrote up a post about this, about J3277, and of course, upcoming changes to it or additions to it, J3277-1. Thanks a lot.
Thank you.
For more information about the evolution of sustainability, head on over to sustainablecareers.sae.org. And if you're not quite ready to add an EV to your household, you can check out our plug-in hybrid explainer video to help bring you up to speed on the hybrid technology and the vehicles. Be sure to subscribe and listen every week on your favorite podcast platform.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.